हेलो बच्चों, गुड इवनिंग। सो इन दिस लेक्चर आई विल डिस्कस अबाउट मैग्नेटिक सर्किट। फर्स्ट तो हम लोग डिस्कस करेंगे मैग्नेटिक फील्ड क्या है, मैग्नेटिक फ्लक्स क्या है, मैग्नेटिक मोटिव फोर्स क्या होता है, एमएमएफ क्या होता है, एनआई कैलकुलेशन, नंबर ऑफ टर्न इनटू करंट। Then we'll talk about the analysis of magnetic circuit. Then we'll discuss about the comparison of electric circuit and magnetic circuit, which is very important. We'll discuss about what is the similarity, what are the dissimilarities. And then we'll discuss about BH curve and hysteresis loop. And last में कुछ problem करेंगे, ठीक है? So magnetic circuit क्या होता है? Coming to the definition, it is a closed path followed by the magnetic flux. ठीक है? So magnetic flux actually क्या होता है? Magnetic flux is nothing but bunch of magnetic field lines through a area. So as you know the properties of magnetic field lines, it always originated from the north pole and terminate towards the south pole. ठीक है? So magnetic flux is nothing but B dot A, the dot product of magnetic field and area. So we can say it is BA cos theta. Magnetic flux is a scalar quantity, but magnetic field is a vector quantity. Remember. Okay? So let us analyze. We'll take a core. To analyze the magnetic circuit, we'll consider a core with high permeability. Usually we are considering soft iron core. क्या है? Soft iron core. Since it has high permeability. So there is a coil which is wounded on the core and we are providing some power supply. The current flowing through the coil is I. So the amount of magnetic flux will set up in the core, that is the function of number of turn and current. More is the current, more is the amount of magnetic flux will be set up, and more is the number of turn, more is the magnetic flux will be set up. So here actually what happens, whenever current is passing through the coil of number of turn n, then MMF will be developed. MMF क्या है? Magnetomotive force. क्या है? Magnetomotive force, which will be equal to n into I, which is equal to n into I, number of turn into current. That magnetomotive force will help to drive this magnetic flux, or will help to set up this magnetic flux inside the core. The flux is phi. Clear? The property of the core, or the property of the magnetic circuit which opposes the magnetic flux, that is called reluctance. That is called reluctance. Like your resistance. Resistance क्या होता है? It is a kind of obstacle. It's a kind of opposition which opposes the flow of current. Similarly, reluctance is a kind of opposition in the magnetic circuit which opposes the flow of magnetic flux. So that is the basic definition of magnetic circuit. I hope it is clear. Okay. Okay, now we'll go for analysis of magnetic circuit. To analyze the magnetic circuit, we have to consider a soft iron core, and this is the winding. Number of turn is N and I is the supply current. So what I've told you, the MMF which will be developed, that is equal to NI. That MMF will help to set up this magnetic flux inside the core, that is phi. And you know that magnetic field is nothing but magnetic flux upon area. As I have told, magnetic flux is a scalar quantity. Magnetic flux क्या होता है? B dot A. So it is BA cos theta. So we are considering maximum flux. So magnetic field is phi upon area. Also we know magnetic field is directly proportional to magnetizing force. H is the magnetizing force. What is the role of magnetizing force here? Magnetizing force, it will help to move a unit north pole from one point to another point by doing some work done, right? So I can write down B is equal to mu into H. Mu is nothing but permeability of the material. So in place of mu, I can write down mu naught into mu r. Mu naught is the absolute permeability and mu r is the relative permeability. So here we can get H is equal to B upon mu naught into mu r. Clear? So I can write down H is equal to B. In place of B, I can write down phi upon A into mu naught mu r. Okay? So now as per the work energy theorem, the amount of work done by bringing a unit north pole from one point to other point is nothing but H into L. अरे H क्या होता है? Force. L क्या होता है? Length of the circuit. So force into length is work done. So मतलब the amount of work done by bringing or by shifting a unit north pole from one point to other point is nothing but inside the magnetic circuit is nothing but H into L. H is the magnetizing force, L is the length of the circuit, magnetic circuit, which will be equal to mmf. mmf क्या है? Ni. मतलब as per the work energy theorem, अरे it is energy, ये तो energy है. So as per the work energy theorem, HL is equal to Ni. ठीक है? So HL is what? Sorry, H is what? Phi upon A into mu naught mu r into L is equal to what? mmf. ठीक है? So phi is how much? mmf into A into mu naught mu r upon how much? L. Done. So I can write here phi is equal to mmf upon L upon A into mu naught mu r. ठीक है? So मतलब magnetic flux is equal to mmf upon this parameter. This parameter is called reluctance. So मतलब magnetic flux is mmf upon reluctance. Okay? जैसे करंट में होता है, करंट क्या होता है? EMF upon resistance. करंट क्या होता है इन इलेक्ट्रिक सर्किट? EMF upon resistance. Similarly, magnetic flux क्या है? mmf upon reluctance. So now tell me what is reluctance here? Reluctance का expression क्या है? What is reluctance? Reluctance is nothing but L upon A mu naught mu r. So that means more is the length of magnetic circuit, more is the reluctance. जैसे resistance में होता है, more is the length, more is the resistance, and more is the area of the magnetic circuit, less is the reluctance. Opposition कम होगा. I think it is clear. Okay, what you conclude from here, like mmf जो होता है magnetomotive force is equal to Ni. That magnetomotive force will help to drive this magnetic flux, right? So as per the work energy theorem, a magnetizing force will be there, which will help to shift the north pole from one point to other point. So magnetizing force into length of the circuit is nothing but work done. ठीक है? ये as per the energy work energy theorem you can compare these two. मतलब HL will be equal to Ni. Remember this is very important. HL is equal to Ni. See mmf अलग होता है, HL अलग है, but दोनों में क्या similarity? It is a work done or energy. It is also work done or energy. HL is equal to Ni. ठीक है? So here I have written the definition of mmf and reluctance. mmf मैंने क्या बोला था? mmf is nothing but it is the product of number of turn and current. It is a product of N and I, which will help to set up this magnetic flux inside the core, right? In other words, we can say it is a kind of energy which will help to drive a unit north pole from one point to other point, or in you can write it is a work done in moving a unit north pole once around the magnetic circuit. To complete the magnetic circuit, the amount of work done is nothing but H into L, magnetizing force into L. That is also you can say mmf, magnetomotive force, which is Ni. Okay? And coming to the definition of reluctance, as I've told, reluctance is a kind of obstacle, it's a kind of opposition which offered by the magnetic circuit. It's a opposition. It is equivalent to resistance in electric circuit. So S is equal to L upon A mu naught mu r. Right? Permeance क्या है? Permeance is inverse of reluctance. जैसे conductance होता है, conductance is inverse of resistance. Similarly, permeance is inverse of reluctance in magnetic circuit. The expression is A into mu naught mu r upon L. So that is all about the definition of mmf, reluctance and permeance. Okay, clear? So now we go for the comparison now between magnetic circuit and electric circuit. So I have mentioned the major comparison. So the closed path followed by the magnetic circuit, magnetic flux is nothing but magnetic circuit. मतलब it is a closed path for magnetic flux. Electric circuit क्या होता है? It is a closed path for current. So what is the source here? Source is mmf, magnetomotive force. What is the source here? EMF, electromotive force. Right? Here magnetic flux circulate, here current circulate. So the formula of magnetic flux is mmf upon reluctance. यहाँ पे current formula क्या है? EMF upon resistance. इस कंपैरिजन करो, समझ में आ जाएगा। ये फ्लक्स है, इधर करंट है, यहाँ पे एमएमएफ, यहाँ पे ईएमएफ, यहाँ पे रिलक्टेंस अपोजिशन, यहाँ पे रेजिस्टेंस अपोजिशन। And what is the unit of mmf? Ampere into turn. What is the unit of emf? Volt. Reluctance क्या होता है? Kind of opposition offered by the magnetic circuit, which is L upon A mu naught mu r. L is the length of magnetic circuit, A is the area, cross-sectional area of the path. And what is resistance? Resistance is nothing but rho L upon A. Rho is the resistivity, L is the length, A is the area of the conductor, cross-sectional area. And here magnetic flux density or magnetic field, which is magnetic flux upon area. But इसमें देखो current density J is I upon area, current upon area, right? So unit is Weber per meter square. यहाँ पे unit क्या है? Ampere per meter square. And what is the mmf drop? That is flux into reluctance. What is the voltage drop? Current into resistance. Comparison करो, यहाँ पे flux, यहाँ पे current, यहाँ पे reluctance, यहाँ पे resistance. Next, what is magnetic intensity or you can say magnetizing force, which is Ni upon L. मैंने बोला था ना, mmf is nothing but Ni, which is HL as per the work energy theorem. So H is Ni upon L. So इसमें देखो electric field intensity is nothing but potential gradient, that is dV upon dr, and minus symbol is there. I have taken, you take the magnitude, which is V upon L, voltage upon length. So that is all about the comparison of magnetic circuit to electric circuit. I hope it is clear. Any doubt? Okay. So now we'll discuss about composite magnetic circuit. Composite magnetic circuit क्या है? It is a series of different magnetic circuit. Different magnetic circuit मतलब we have different magnetic material with different dimension. Then we'll have to find out what is the total MMF, total magnetomotive force. Let us consider a composite magnetic circuit like, okay, this is a magnetic materials of, let it be area A1 and length L1 and relative permeability is mu1, right? And we connect another, along this we connect another magnetic material of cross section area A2 and length L2 and permeability mu R2. Okay, and next we'll connect another magnetic material of area A3, length L3 of magnetic permeability, relative permeability of mu R3. So there are three magnetic material and one air gap is also there. Air gap में relative permeability is mu naught, which is absolute permeability, and area is, let it be AR and length is LR. Okay, we'll find out what is the net EMF. We'll have to find out what is the net MMF, magnetomotive force. Okay, so so total reluctance will be what? Individual reluctance, ये S1 first का reluctance, S2 second का reluctance, S3 reluctance of third one, and SG is reluctance of air gap. So what is the net reluctance? Since all are connected in series, net reluctance is S1 plus S2 plus S3 plus SG, right? So reluctance का formula मैंने क्या बोला था? What is reluctance? What is the formula of reluctance? L upon A mu naught mu r. That is the formula of reluctance. ठीक है, so S1 क्या हो जाएगा? Reluctance S1 क्या हो जाएगा बोलो? L1 upon A1 mu R1, sorry mu naught into mu R1 plus S2 क्या होगा बोलो? L2 upon A2 mu naught mu R2 plus S3 क्या होगा? L3 upon A3 mu naught mu R3 plus Sg क्या होगा? रिलक्टेंस ड्यू टू एयर गैप, इट इज Ag mu naught, ओनली mu naught, राइट? ठीक है, ये हो गया टोटल रिलक्टेंस. सो एमएमएफ क्या है? एमएमएफ इज नथिंग बट मैग्नेटिक फ्लक्स इनटू टोटल रिलक्टेंस. सो मतलब एमएमएफ विल बी इक्वल टू phi, you can put this expression here. So it will be L1 A1 mu naught mu R1 plus L2 A2 mu naught mu R2 plus L3 A upon A3 mu naught mu R3 plus LG upon AG mu naught. ठीक है, Okay, so mmf will be equal to ये हो गया टोटल mmf, ठीक है, इसको अभी मल्टीप्लाई कर दो. So mmf will be equal to phi into L1 upon A1 mu naught mu R1 plus phi L2 upon A2 mu naught mu R2 plus phi L3 upon A3 mu naught mu R3 plus phi into Lg upon Ag mu naught. ठीक है, यहाँ तक क्लियर. नाउ phi upon A1 is nothing but B, मतलब B1 into L1 upon how much mu naught mu R1 plus phi upon A2 क्या है B2 मैग्नेटिक फील्ड अपन क्या है mu naught mu R2 into L2. Similarly phi upon A3 is what B3 upon mu naught mu R3 into L3 plus what is phi upon Ag, that is Bg magnetic field due to air gap upon mu naught into Lg. ठीक है, so final expression of mmf will be, see, B upon this one is H, magnetic field upon this one mu naught mu R is H. अरे मैंने बोला था ना B is equal to mu naught mu R into H. So मतलब B1 upon mu naught mu R1 will be how much H1. So it will be H1 into L1 तो there. ये क्या हो जाएगा H2 into L2. ये क्या हो जाएगा H3 into L3. ये क्या हो जाएगा Hg into Lg. So ये हो गया आपका फाइनल expression of mmf. मतलब total mmf will be the sum of individual mmf. You can say h1 l1 plus h2 l2 plus h3 l3 plus hg lg. I think that is all about composite magnetic circuit. Now coming to another point, BH curve. BH curve क्या होता है? The graph between magnetic flux density with respect to magnetizing force or magnetic field intensity, you can say. That means with respect to age or with respect to the variation age, what will be the variation of B? See, as you know, B is directly proportional to H. So B is equal to some constant, proportionality constant into H. Actually, it is not constant. It is called permeability of the magnetic material, which is equal to mu naught into mu R. Mu R is the absolute permeability and mu R is the relative permeability. That permeability of a particular material is constant. Okay, that side is called proportionality constant. Understood? So B is, since B is equal to mu into H, so that means if we increase the value of H, B will increase. So the graph will be like this, linear. From A to B, you can see here it will be linear. But beyond B, that B will not follow H linearly because of saturation property of the magnetic material. Any kind of magnetic material will have its own saturation property. So with certain extent, B is directly proportional to H. Beyond that, it could not, right? So matlab B, the nature of B will be linear with respect to H from A point to B point, or you can say from O point to B point. After B point, saturation occurs. That is also called Ni values. Okay, और threshold value, maximum saturation value, saturation हो गया, ठीक है. देखो, if I increase the value of H, B will not increase. Clear? Next, coming to magnetic hysteresis. What is magnetic hysteresis? The definition is it is a phenomenon of lagging of magnetic flux density B behind H in a magnetic material which is being subjected to cycle of magnetization. So to analyze this one or to understand this one, we will take an example of solenoid. As you know, the magnetic field inside the solenoid is nothing but mu naught into Ni. N is the number of turn upon unit length. So here we have considered a solenoid, and the solenoid is being energized through a power supply with a rheostat or variable resistor. So here what will happen, if I increase the value of current, if I increase the point number 1, if I increase the value of current, H will increases, magnetizing force will increases. It will help to drive this magnetic flux, so B will increases, right? So that means, look at this, if we increase the value of H, then B will increases, so B will follow this path. Then at a certain point saturation occurs, right? Due to the saturation property of this magnetic material, if I increase the value of h b will not increase. Matlab h is a function of I. We can increase the value of I as much we want since we have power supply. That doesn't mean b will increases linearly. So b will increases up to certain point, then saturation occurs. So that means up to certain point B will increases. So that path will followed through this one OA. Second point, then I have to decrease the value of current. If I decrease the value of current by changing the pointer of rheostat, then obviously H will decreases because H is a function of I. H is magnetizing force. Then B will also decreases, but B will not follow this path. B will follow this path. Understood? So at this point, look at this point here, we have magnetizing force or magnetizing field intensity H is 0. Matlab if I decrease the value of current, H will decreases. At certain point I'll be getting current as 0, matlab H will be 0, still we'll have some B. Matlab at this point, look at this point, at this point your current is 0, H is 0, but still we have some magnetic field. So that is due to residual flux density, and this power which will help to retain that residual flux inside the core is nothing but retentivity. Again I repeat, at this point B, the value of I will be 0, the value of H will be 0, but still we'll be getting some magnetic field due to the residual property of magnetic material. That means it will gain some power which will help to retain some magnetic field. That is called retentivity. Matlab OB is called retentivity, or you can say positive retentivity. बेटर होगा पॉजिटिव रिटेंटिविटी. ठीक है. नेक्स्ट ये दो लाइन क्लियर. नेक्स्ट थर्ड पॉइंट, then if I change the polarity here, then negative current will increases, matlab negative H will increases, that means negative B will increases. So here look at this graph from B to C, negative I will increases, negative H will increases, so negative B will increases, but we'll have some positive B. Then first of all B has to be 0, so we'll have to make B as 0. So matlab at this point we have some negative current, we have some negative H, but magnetic field is 0. So this OC is nothing but cohesive force. So cohesive force is nothing but it is a negative magnetizing force which will make B as 0. Again I repeat, cohesive force is a negative magnetizing force due to negative current which will help to keep the magnetic field as 0. अंडरस्टूड. यहाँ तक क्लियर. नेक्स्ट फोर्थ पॉइंट, नेगेटिव सैचुरेशन के बाद इफ आई डिक्रीज द वैल्यू ऑफ नेगेटिव करंट, नेगेटिव एच विल डिक्रीज. सो इफ नेगेटिव एच विल डिक्रीज, नेगेटिव बी हैज टू बी डिक्रीज, राइट. सो नेगेटिव बी भी डिक्रीज हो रहा है धीरे धीरे, देखो. ठीक है. सो एट दिस पॉइंट विल फाइंड एच बिकम 0 सिंस करंट बिकम 0, but b has some negative value, b has some negative value. So similarly the cycle will be continuing. So here what you conclude, we will take any point here, we will find a lagging of B behind H. So this loop is called hysteresis loop. ठीक है. So most important point याद रखो, OB is nothing but your residual flux, and that is nothing but positive retentivity, and OE is called negative retentivity, and here OC is nothing but cohesive force. OF is also cohesive force, right? So there are two cohesive force and two retentivity. One is positive, other is negative. Clear? Look at the question. Here it is given an iron ring has cross-sectional area of 400 millimeter square and mean diameter of 25 centimeter. It is wounded with 500 number of turns. Relative permeability of the material is given 250. And you have to find out the total amount of flux that will be set up in the ring if the coil resistance is 474 ohm and supply voltage is 240 volt. So see, there is a ring, it is a circular ring, right? Iron ring. A cross sectional area is given, 400 millimeter square. Okay. And average diameter is given, how much? 25 centimeter. And it is wounded with 500 turns. ये 500 turns of a coil, it is wounded. here the supply voltage is given. What is the supply voltage? The 240 volt, and the coil resistance is also given, 474. So from the statement, from this side we can find out current flowing through the coil. Current is voltage upon resistance. Voltage is 240, resistance is 474. ये तो current मिल गया, ठीक है. So we can find out mmf. mmf is what? Ni. mmf is nothing but Ni. So number of turn is 500. I is 240 upon 474. ये जो Ni is nothing but H into L. मैंने बोला था Ni is nothing but H into L, magnetizing force into L. So here you can find out H by dividing L here. और इसमें divide कर दो 500 into 240 by 474 into how much? L. It is clear? दिखाई नहीं दे रहा है? और ठीक है, तो यहाँ तक दिखाई दे रहा है, ठीक है. So मतलब here we can find out H. H is nothing but Ni upon L. Ni क्या है? 500. I कितना है? 240. 474 by length of the circuit is given. Length क्या है? Length कैसे मिलेगा? Diameter is given. मतलब ये क्या है? Pi d. अरे length circumference क्या है? 2 pi r. Length is 2 pi r. 2 into r is diameter, so length will be pi d. Clear? So we can put this value. You calculate it. You put the value and get the answer. H मिल जाएगा. अरे everything will given. You just find out the value of H. H मिलने के बाद क्या करोगे? देखो, you know that B is nothing but mu into H. mu क्या है? mu naught into mu r. ठीक है. So mu naught क्या है? 4 pi into 10 to the power minus 7. And mu r is given. mu r कितना है? 250. H already you calculated from here. You put the value. क्या मिल जाएगा? B मिल जाएगा. Any doubt? You calculate and write in comment box. मैं calculation नहीं कर रहा हूँ, ठीक है. So ये B मिल गया. B मिलने के बाद क्या चाहिए हमें? हमें क्या चाहिए? Find the total flux. Flux का फॉर्मूला क्या है? B into A. अरे B is equal to flux upon area. Magnetic field is magnetic flux upon area. Flux is magnetic field into area. So B तो यहाँ से मिल गया. एरिया इज गिवन. एरिया कितना है? 400 मिलीमीटर स्क्वायर. इसको मीटर स्क्वायर में कन्वर्ट करो, देन डाल दो, आंसर मिल जाएगा. आई थिंक इट इज क्लियर. आई एम नॉट गोइंग टू कैलकुलेट, जस्ट मैंने कॉन्सेप्ट बोल दिया कैसे कैसे करना है. सर्कुलर रिंग इज गिवन, मतलब लेंथ यू फाइंड आउट 2 पाई आर और पाई डी, राइट. And supply voltage is given, number of turn is given, resistance is given. If resistance is given, you can fast find out current. Current into number of turn is mmf. Mmf is nothing but HL. H is magnetizing force. L is the length of the circuit, a magnetic circuit, length of the magnetic circuit, which is 2 pi r or pi d. Then यहाँ से तुम्हें H मिल जाएगा. H अगर मिल जाएगा, then B मिल जाएगा. B is mu into H. म्यू क्या है? म्यू नॉट इंटू म्यू आर. म्यू नॉट इज 4 पाई इंटू 10 टू पावर माइनस 7. म्यू आर का वैल्यू इज गिवन 250. एच तो यहाँ से मिल गया, देन बी मिल जाएगा. बी मिलने के बाद फ्लक्स मिल जाएगा, बी इंटू ए. एरिया इज गिवन. क्लियर? नो डाउट. Okay, look at the question. A magnetic flux density of 1.2 weber per meter square is required in 2 millimeter air gap of an electromagnet having iron path of 1 meter. Calculate the total mmf is required. So it is a very interesting question. It is a kind of composite magnetic circuit. It has two parts. One is air gap. Second is iron path. Right? Iron path. ठीक है. So we'll have to find out the total mmf. mmf का फॉर्मूला मैंने क्या बोला था? mmf is nothing but ni or h into l. मतलब we'll find out h of air gap plus l of air gap plus h of iron into l of iron path. That we have to find out. ठीक है. दोनों को ऐड करना है. It's very simple. We know B is equal to mu h. H का फॉर्मूला क्या है? B अपन H का फॉर्मूला क्या है? B अपन mu. ठीक है. बट दोनों के लिए B is constant 1.2 weber per meter square. दोनों के लिए B constant क्योंकि both are connected in series. सो टेल मी एच ऑफ एयर गैप कितना होगा, बी ऑफ एयर और बी अपॉन म्यू ऑफ एयर। म्यू ऑफ एयर मतलब क्या है, म्यू नॉट, ठीक है। सिमिलरली एच ऑफ आयरन क्या होगा, बी अपॉन म्यू ऑफ आयरन। म्यू ऑफ आयरन मतलब क्या है, म्यू, that is nothing but mu naught into mu r। म्यू आर इज गिवन, म्यू नॉट यू नो, म्यू नॉट का वैल्यू क्या है 4 पाई इंटू 10⁻⁻⁷। इसमें भी सेम थिंग। सो मैग्नेटिक फील्ड का तो, अरे ठीक है मैं कर रहा हूँ, देखो 1.2 म्यू नॉट कितना है 4 पाई इंटू 10⁻⁷। हियर 1.2 अपॉन 4 पाई इंटू 10⁻⁷, म्यू आर कितना है 1500। सो जो भी है तुम्हें मिल जाएगा एच ऑफ एयर गैप, एच ऑफ आयरन, ठीक है। देन लेंथ इज गिवन, एयर गैप का लेंथ कितना है 2 मिलीमीटर, इसको मीटर में कन्वर्ट कर दो। एल ऑफ एयर गैप इज गिवन 2 मिलीमीटर। लेंथ ऑफ आयरन पाथ इज गिवन हाउ मच 1 मीटर, ठीक है। तो इसमें डाल दो, अंडरस्टूड। इसमें डाल दो, दोनों को ऐड कर दो, आंसर हो जाएगा। सो आई एम नॉट गोइंग टू कैलकुलेट इट, यू डू इट, मैंने जस्ट कॉन्सेप्ट बोल दिया कैसे करना है। So with this, I am ending this session. Hope you guys understood. So thank you so much for watching my video. Thank you so much. Thank you.